Good morning, students. Now, so far we covered maximum portion from the magnetism, but in this class we will focus on the diamagnetic substance, paramagnetic substance, and ferromagnetic substance. See, based on the magnetic properties, the substance can be classified into three types. They are diamagnetic substance, paramagnetic substance, and ferromagnetic substance. And first one is diamagnetic substance. The material which are weakly magnetized, the materials which are weakly magnetized in a direction opposite to the applied magnetic field is called diamagnetic substance. Now, based on the electron theory, how it is weakly magnetized, we show one by one. See here, in a diamagnetic substance, the electrons are existing pairs. See here, this is the one electron, this is the other electron. Here it is positive charge is there. This is the direction of first electron. This is moving in anti-clockwise direction, and this is the second electron, which is moving in clockwise direction. Clockwise direction. Because of this movement of electron in anti-clockwise direction, its magnetic moment it is acting in downward direction. Here the magnetic moment is acting in upward direction, and that is the reason when there is no magnetic field is applied on diamagnetic substance, the net magnetic dipole moment is zero. That is the reason it is not attracted. Now, when the magnetic field is applied, how it is applied? It is applied perpendicular to the plane of the board like this. Perpendicular to the plane of the board, that is into the plane of the board. Perpendicular to the plane of the board. Now, in such a condition, this electrons, if it is moving in magnetic field, definitely the force due to magnetic field will be acting. How it is acting? First, if it is moving circular path means centripetal force will be acting. That is acting towards the center. This is the centripetal force. And force due to magnetic here in the first electron it is acting upward direction, and for the second one it is acting in the same direction, that is towards its center. So that is the reason in one electron centripetal and force due to magnetic both are opposite direction, but in second case the centripetal force and force due to magnetic both are acting in the same direction. That is the reason here the velocity is decreasing, here the velocity is increasing. Now that is the reason here you see the velocity v1 is equal to v0 minus delta v decreasing, but here the velocity v2 is equal to v0 plus delta v. That means here the velocity is decreasing, here the velocity is increasing. And how this magnetic moment and velocity are related? They are directly proportional. So that is the reason here the magnetic moment is decreasing, here the magnetic moment is increasing. And finally, the net magnetic moment we can get the subtracting m0 plus delta m minus m0 plus delta m. This m0 m0 cancel. So finally we get 2 delta m. Finally, in the presence of magnetic field which is applied on the diamagnetic substance, then the net dipole moment is doubled, but how it is acting? It is acting perpendicular to the plane of the board, that is outward direction. Magnetic field is acting perpendicular to the plane of the board inward, but the anti-dipole moment is acting outward. So that is the reason the applied magnetic field and induced magnetic field both are opposite. That is the reason here a weak magnetism is developed in a diamagnetic substance. Examples of diamagnetic substance: gold, silver and copper. These are considering as a best examples for diamagnetic substance. So once again, you see the materials which are weakly magnetized in a direction opposite to the direction of applied magnetic field. It is called diamagnetic substance. Example: gold, silver and copper. Now based on the electron theory, now we know how it is opposite magnetism is developed. We'll see one by one. See, in every atom, the electrons are exist in pairs. One electron is moving with velocity v1, it is moving anti-clockwise direction, and second one it is moving with clockwise direction. If the magnetic field is not applied, then each one magnetic moment is one is downward, one is upward. That is equal and opposite. That is the reason the net dipole moment value is 0. That is the reason it will not exhibit any magnetism. When the magnetic field is applied, here the magnetic field is applied perpendicular to the plane of the board, that is into the plane. Then because of this magnetic field, this electron will experience a magnetic force. One is acting opposite to the centripetal, and second case it is acting towards the centripetal force. So that is the reason both are here. The velocities are decreasing, here the velocities are increasing. In the first case, the velocities are decreasing. That is the reason the magnetic moment is also decreasing. But in the second case, the velocities are increasing, magnetic moment is also increasing. So that is the reason here magnetic moment is increasing, magnetic moment is decreasing. But finally, the net magnetic dipole moment is acting vertically upwards, magnetic field is acting downwards. Because of this one, the induced magnetism, which is produced opposite to the direction of applied magnetic field. So finally, a weak magnetism is produced in a material. And second one is paramagnetic substance. Paramagnetic substance. Now see here in the paramagnetic substance, here I am taking one substance. In that substance I am considering the electron movement. The electrons are orienting in particular direction and they are spinning in their own direction. Now this is a particular electron, it is have a dipole moment. Another electron, another electron, another electron, like this. Now see here, if the magnetic field is not applied, each electron will have orienting in different directions because of their room temperature. Because of the thermal motion, each one has one dipole moment, but then each one is showing in different directions. So that is the reason at ordinary temperature, the net dipole moment will be, if you are adding all the direction, the net dipole moment will be 0. That is the reason a paramagnetic substance at particular temperature, it will not show any magnetism. But if the external magnetic field is applied, then what is happening? All these different directions, electrons are orienting in particular direction, like this. These are orienting in one particular direction. That is the reason the net dipole moment, if you are adding all this, the net dipole moment will be present. But at this particular temperature, these are not strongly aligned. If they are all strongly aligned means, then definitely magnetism will be more. But these are not completely aligned in particular direction. That is the reason a weak magnetism is produced. Such type of materials we call it as a paramagnetic substance. It is a substance in which a weakly magnetism is produced when the magnetic field is applied. That we call it as a paramagnetic substance. And third one, substance. Ferromagnetic substance. In paramagnetic substance, the examples are aluminium and chromium. Aluminium and chromium. In ferromagnetic substance, the best examples are iron and nickel. Iron and nickel. It is a substance which it is strongly attracted by a magnetic substance. Such type of substance when magnetic field is applied is called as ferromagnetic substance. The best examples are iron and nickel. Now, in this ferromagnetic substance, we have to consider the domain theory. See here, like this it is there, like this it is there. Now, initially, this is one particular domain, this is the other domain, and this is the other domain, and this is the other domain. Is here the domain is nothing but a small region in which a large number of atoms are present, that we call it as a domain. Now, in this particular domain, all these atoms are aligned in one particular direction. That is the reason these will have one particular dipole moment. Similarly, here this is the other dipole, this is the other dipole, and this is the other dipole. But at ordinary temperature, if there is no external magnetic field is applied at that condition, each one have their own dipole moment in its own direction. But all these are in different direction. So that is the reason they will not exhibit any magnetism. But if the external magnetic field is applied, then all these atoms are aligned in one particular direction. Which direction? This is the way they are aligned. This is the direction they are aligned. So that is the reason if all the domains are showing the net magnetic field direction, they are showing in one particular direction, same direction. That is the reason in that substance a strong magnetism is developed. Strong magnetism is developed. Suppose if the temperature, based on the temperature, if they are aligned in one particular direction at one particular temperature, if all these domains, separation domains are there, but they are aligned into one single domain, in that condition, a strong magnetism is produced in the substance. Suppose if the temperature is increased, then at particular temperature, the boundaries of these domains will break. At that condition, it will lose the magnetism. At the temperature at which ferromagnetic substance becomes paramagnetic substance, the temperature we call it as a Curie temperature. Curie temperature. The temperature at which ferromagnetic substance becomes paramagnetic substance, that temperature we call it as a Curie temperature. And one more law we can get from this explanation. What is that one? The susceptibility and temperature, these are related inversely proportional, and this we call it as a Curie's law. The susceptibility of substance is inversely proportional to its temperature, and that we call it as a Curie's law. So once again, now based on this diamagnetic electron theory, paramagnetic theory, and ferromagnetic substance theory, now totally we can study the differences of this dia, para, and ferromagnetic substance one by one. See. Now see, first one, ferro, para, and third one, dia. Students, this is highly important question. Every year, based on this one, definitely you will get one question, either properties of dia, properties of para, properties of ferro, or Comparison of dia, para, ferro. So compulsory you must learn this question. Now see one by one. The substance which is strongly attracted by a magnet, that we call it as a ferromagnetic substance. The substance which is weakly attracted by a magnet, that we call it as a paramagnetic substance. The substance which is repelled, by a magnet, that we call it as a diamagnetic substance. Strongly attracted, weakly attracted, repelled by magnet. Second one, example, ferro, iron, nickel. Here the example, aluminium and chromium. Here the example, gold and silver and copper. When the ferromagnetic substance is hanged in a magnetic field, it aligns in the direction of north and south. When the ferromagnetic substance is hanged, it is placed in a uniform magnetic field, it aligns, finally it comes to rest in the direction of north and south. And here also it comes to rest in the direction of north and south. But here diamagnetic comes to rest in the direction of east and west. Direction. Now, if the ferromagnetic substance is placed in a uniform magnetic field, the maximum magnetic field lines prefer to pass through them. Magnetic field lines prefer through them. Here also the magnetic field lines prefers to pass through them, but here the magnetic field lines do not prefer to pass through them. Next, here the permeability value is much greater than 1. Here the permeability value is just greater than 1. Here the permeability value is less than 1. Next, here the magnetization M value is large positive value. Here the magnetization value is positive. Here the magnetization value is negative. Next, here the susceptibility value is positive, more positive. Here the susceptibility value is just positive. Here the susceptibility value is negative. And lastly, the ferromagnetic substance obeys Curie's law, and paramagnetic substance also obeys Curie's law. And here the diamagnetic substance do not obey Curie's law. Now, once again, all of you see the diagram. You see all these points one by one. See, ferromagnetic substance, paramagnetic substance, and diamagnetic substance. See, ferromagnetic, the substance which is strongly attracted by a magnet is called ferromagnetic substance. The substance which is weakly attracted by a magnet is called paramagnetic substance. The substance which is repelled by a magnet is called diamagnetic substance. The best examples for ferromagnetic substance: iron, nickel; for para, aluminium, chromium; for dia, gold, silver, copper. When the ferromagnetic substance is kept in a uniform magnetic field, it immediately aligns in the direction of applied magnetic field, that is north and south. In the same case, it happens for paramagnetic also. when the paramagnetic substance, if it is hang and keep it in a magnetic field, it comes to rest in north and south direction. But when in case of diamagnetic substance, it comes to rest opposite to the direction of applied magnetic field, that is east and west. Now, if the ferromagnetic substance is kept in a magnetic field, the maximum magnetic field lines are preferring to passing through this substance. Whereas in case of paramagnetic also, the maximum field lines prefer to pass through them, but in case of diamagnetic, they never prefer to pass through them. Next, in ferromagnetic, the permeability, the ability to pass through the magnetic field lines will be called as a permeability. That value is much greater than 1. I already told you the fourth point and fifth point, they are related to each other. The permeability value is much greater than 1. In case of para, the permeability value is just greater than 1. In case of dia, the permeability value is less than 1. Whereas in case of magnetization is concerned, the ferromagnet is more positive. For para, it is less positive. For dia, it is negative. Next, when it comes to susceptibility, the ferromagnetic susceptibility is more positive. Susceptibility for para is less positive, and susceptibility for dia is negative. And lastly, the ferromagnetic substance obeys Curie's law, and paramagnetic substance also obeys Curie's law, and diamagnetic substance, it doesn't obey Curie's law. And in this one, we already know two more important definitions. What are they? Curie's temperature and Curie's law. Curie's law, how this susceptibility and temperature are related. The susceptibility and temperature both are inversely proportional, and that we call it as a Curie's law. And what is the Curie's temperature? The temperature at which ferromagnetic substance becomes paramagnetic substance, and that temperature we call it as a Curie's temperature. So everybody must learn this classification of materials based on magnetism, that everybody must learn this question.